Hi, my name is ShaynaDeltano, and I'm an intern in the femtosecond laser lab at Boston University. In any field of science, it's important that we know the measurement not only of our results, but also of our tools. In physics, one commonly used tool is a laser, and one measurement we want to know about a laser is its pulse duration. A pulse is a flash of light in the laser, where instead of a continuous wave, there is one wave that occurs multiple times. Pulse duration is the length of the pulse, which is measured in a unit of time. However, there's one major issue when it comes to measuring pulse duration. Where in normal pulse durations, we can find it using technology like sensors or cameras. When the pulses are very fast, we can't use the same technology. With femtosecond lasers, it occurs in the femtosecond time scale, which is 1/millionth of 1/billionth of 1 second. So now what do? The solution to this problem is an optical autocorrelator. Autocorrelators are able to bypass this issue by comparing the pulse against itself. And while it may sound complicated, we've had this technology for decades, and it's the best way to measure pulse duration. So how do we understand autocorrelators? Well, consider two waves in the ocean. When two waves collide at their peak intensities, it causes a very big splash. However, if we could delay one wave in time, when they collide, there'd be a much smaller splash. Now, imagine doing this collision tens or hundreds of times with multiple delays. This same process is what an autocorrelator does, but instead of waves of water, it's waves of light. In my project, I was tasked with creating the delay stage of the autocorrelator, which causes one beam of light to be delayed in space. I was able to delay it forwards and backwards, and I was able to optimize the process using an estimated pulse duration. Knowing the pulse duration of a laser is critical to the success of any experiment. Because of their speed, femtosecond lasers are perfect to observe, like the flash of a camera, any event that happens on a very short timescale, like the movement of atoms or chemical reactions. These things are historically stuff that we've never been able to see before, so having a femtosecond laser is a great tool that we can use. An autocorrelator is also a great tool that we can use not only to measure pulse duration, but also to see if there are any errors in our experimental setup. As we move full speed ahead with this research, it's time that we slow down and take the measurements we need to have precise and accurate setups for our experiments. Thank you.